It's 83 centimetres.
Contemporary management, and it might be data assessment, could be particular survey information. Aboriginal people, Torres Strait Islander people collect similar information through those conversations, but there's certain indicators out there. If things are different to last year, if it's harder to catch a particular species at the same time that you were in the same place last year, then that's an indicator in itself.
Stock assessments try to understand how much fish is in a stock and how that stock is changing over time. If we wanted to do a stock assessment of our billabong, then we can't drain it to count the fish, so we need other methods. One of these methods is a tag recapture experiment. For example, if we catch and tag 10 fish from the billabong and release them back into the population, here they are, represented by the gold-coloured fish. Over time, these fish mingle with the rest of the population. We can now use the number of tagged fish that are recaptured to work out an estimate of the population. So, how this works is if we catch 10 fish and one of those is tagged, then in our sample 1/10 of the fish are tagged. That makes our population estimate for the billabong 100 fish. But most fisheries aren't as simple as the billabong, and it's not so easy to do tag and recapture experiments. Stock assessments vary in complexity from very basic to very sophisticated. One thing that is common in many stock assessments is to use catch and effort information.
For example, like yesterday we went out and we went netting. When we actually caught the salmon, as you're working through collecting the salmon, and that indicates what's actually going on coming along the coast.
So, if fishers report higher catches, does that then mean there are more fish? Well, no, not necessarily. Going back to our billabong example, we will look at how catch can change over time and what that may mean for the fishery. The best way to demonstrate this concept is with a graph. Our graph will show catch and time, with this line representing time and this line representing catch. Let's look at the catches from the billabong over 10 years. You can see that the catches have varied a bit from year to year, but over the whole 10 years there's been no overall trend up or down. If we were just looking at the catches alone, you would assume that the population in the billabong is reasonably stable. The problem with this assumption is that we haven't considered the number of fishers on the billabong and the number of hooks they are all using to catch the fish. This is called fishing effort. Over time, the number of fishers on the billabong has gone up considerably, which means fishing effort has also increased. This changes our understanding of what's happening to the size of the stock in the billabong. We need to take into account how much fishing effort has been used to catch the fish. This measure is called catch per unit effort, also known as CPUE or catch rate. Simply put, this is the catch divided by the fishing effort. Going back to our graph, if we calculate CPUE and put it on this line, overall it has been going down over time. This would suggest that the stock in the billabong is decreasing. Understanding CPUE is very important. It is fundamental to every stock assessment and is the most commonly used indicator of stock biomass. As Linda explains, understanding catch rate is important to managing fish stocks.
And this is pretty exclusive. It's only family members and their friends that come in. So that's how we manage this area here. But down there on the river where it's open to the sea, it's very difficult to manage.
So determining catch rates is important, but a stock assessment that only uses this measure in its calculation is still very basic. The main problem with relying on catch rate as a measure is that it assumes catch rate and stock biomass go up and down at the same rate. However, this is often not the case because there are many other factors that can affect catch rates and blur this picture further. Examples might be availability of the fish to fishers, which species fishers target, environmental conditions, time of day, season, and there are many other factors, as Rob Chewing describes here.
One year you might get fish that are biting a lot more savage, and then in another year you'll get fish that are not as aggressive. And that just might be because of the moon, or it might be because of something going on where, the fish have got hungrier.
The more of these factors that can be included in catch rate calculations, the clearer this picture becomes. We have mentioned two simple methods for doing a stock assessment: tag and recapture and catch rate analysis. Although stock assessments can be far more complicated, these two methods are fundamental to most stock assessments. The type of stock assessment used largely depends on the amount and quality of information available.
The information that Aboriginal and Torres Strait Islanders do bring is over millennia. We know it's been 60,000 years plus. But I keep telling people it's more than sitting down watching the tide come in and out. Understanding the fishing cycles, understanding the fishing patterns,